So today what we want to do is we want to take a look at comparing, computing, and interpreting statistics. Now we've learned a little bit about statistics so far. Statistics are measurements that we can use to interpret specific data sets. So the first thing we're going to look at today is we're going to look at Part 1, Central Tendency. Now, a tendency is something that, well, we're tending to do, something that we're approaching or that we would normally do. And so we're going to try to measure the center of a data set. We want to see what the data is tending to get close to. There's 3 different ways to measure the center of a data set. Here's the first one. The first one is called the mean. It's one that you've used a lot. The mean is the sum of the data divided by the number of pieces of data. The median. The median is the middle number once the data is written in order. The third is the mode. The mode is the piece of data that occurs the most often in a data set. Now, a mode can be one number, meaning it has one mode. We can have no mode. We could also have 2 modes, and therefore it would be called bimodal. And we could have up 3, 4, 5 modes along the way too. So let's show you how these 3 central tendencies work with this particular example. The example that I have for you is the number of vehicles owned. And so in surveying 5 people, we have people that have owned 8, 11, 7, 8, and 9 vehicles respectively. If we want to find the mean, what we would do is we would add up 8, 11, 7, 8, and 9. And if we kind of combine some things, we've got 20, 36. It looks like we've got 43. Now, we divide that by the number of pieces of data, which is 5. In this case, we're going to get 8.6 vehicles. Now, that means if we were to survey somebody, we could expect that the next person we survey would say they had about 8.6 vehicles, if we were talking about the mean. Now the median is the middle number that we can expect from our data set. And so the first thing we have to do is put our data in order. 7, 8, 8, 9, and 11. The median is the middle number. And so the middle number in this case would be 8. This tells us that in our data set that 50% of the data is below 8, 50% of the data is above 8, the middle number. Now the mode is the number that appears the most often. And in this case the mode is 8 because there are 2 of them. If there are 2 8s and 2 9s, then 8 and 9 are both the mode. Now, we have from time to time an outlier. And an outlier is a piece of data that's really far away from other values of data. For example, in our past data set, we had 8, 11, 7, 8, and 9. Well, what if we were to ask another person? And now we have, somebody that has owned 24 vehicles. What effect does this number have on everything? Well, this 24 is an outlier. It's far away from the other pieces of data. Now, what does this do to the mean? Well, our mean now would be, we had 43 for a total, and now we have 67 cars total owned between 6 people. And what that did is it jumped everything up to about 11.2 in terms of our mean. So that one number really skewed the data farther up to the right. Now our median, let's see what effect it had. So now if we put our numbers in order, we've got 7, 8, 8, 9, 11, and 24. Now the middle number that we're looking for, well, there really isn't a middle in this case in terms of the data set. So the middle is going to fall in between the 2 numbers that are in the middle, which is between 8 and 9. So to find the median, if we have an even number of pieces of data, we take the mean of 8 and 9. And so our median in this case would be 8.5. Our mode, Well, we still have the 8 that happens the most often, so that wasn't affected. So the median was affected a little bit, the mean was affected a lot. And so if you've ever taken a test and you have like an 85% and you would get like a 10%, well, that one test can really affect you a lot depending on the time of year you're in. So speaking of exams, let's use our data and use these statistics to find a piece of missing data. You're taking a 4-part exam requiring a mean score of 80 to obtain your license. Your scores on the first 3 parts are 84, 76, and 91. What is the minimum score needed on part 4? Now you'll notice I added those 3 numbers together. And there's going to be a 4th score. Now because there's going to be 4 scores, I'm going to divide by 4, and this has to equal my mean score, which would be 80. So what I can do, first of all, is if I multiplied both sides by 4, that tells me I need 320 percentage points total. And what happens when I multiply by 4 is the multiplying and dividing by 4 goes away. So in doing all of that, I need to go ahead and add up everything on the top now. And that's going to give me a total of 251 plus x. So I have 251 right now. I need 320. So if I take 251 away, I get a missing test score that I need of x equals 69%. So things are looking pretty good. If my lowest score so far is 76, well, hopefully that I can go ahead and make the 69% and go ahead and get my certification and get my license. So those are central tendencies. Okay? Measuring the center of a data set with the mean, median, and mode. Now, there's something else that we can do to look at data, and that is we can measure the spread of the data, and that's called its variation. Now, there's 2 ways. In fact, there's more than 2 ways to do this. One is we can find the range of the data set, and that is the difference of the high and the low. Now, if we take the high number in the data set minus the low number in the data set, we're only using 2 data values. So the range, it gives us the high minus the low, but in terms of using everything, it really doesn't. It just uses those 2 measures. Now, the standard deviation is a measure of variation using all of the data that we have. Now, with that being said, what I can tell you about the range and the standard deviation is the range is pretty easy to compute. The standard deviation has its own formula, and a lot of statistics have their own formulas along the way as well. So what I want to do is I want to take a moment and share with you what they really mean. So let's say that we've got a data set, and our data is going to be in the shape of this distribution right here. Okay, so let's say that let's say we have a data set, and 71 is the lowest number, and let's say 200 is the highest number. All right, so if we want to calculate our range is found by taking 200 minus 71. So our range in data is equal to 129. And that shows the spread of the data. It's pretty spread out. That's what that means. Now, a standard deviation. Let's say that this is the mean. And the mean, let's say, of all of our data is, let's just make up a number and say it's 112. Okay. Now, we're going to say we have a specific standard deviation. We've done the calculation, and again, you won't do the calculation right now. You will in the future. Let's say we get a standard deviation of, well, let's say 5. All right, now what does that mean? Well, a standard deviation of 5 means this. Okay, if I went from 112 over to the right by 5, I would end up at 117. And if I were to go from 112 to the left 5, by subtracting, I would end up with 107. A standard deviation tells us something statistically, that in this orange area, the orange area represents 68% of the data would be in this orange region right here. That's what we can expect. So this whole region in the middle, 68% of our data we say is going to fall within one standard deviation of the mean. And again, the 112 is the mean. We'll make a note of that. Now, let's go out a little farther. Let's add another 5 to 117 and get to 122. And take 107 minus 5 and get to 102. Now, according to statistical analysis, anything from the green in within 2 standard deviations. So here's a standard deviation, here's a second. So plus or minus 2 standard deviations, we can expect 95% of our data to be within 2 standard deviations. That means that 95% of our data is going to be between 102 and 122. Now, in the yellow section, if we go out another 5, which takes us to 127 and to 97. In the yellow section in between there, yellow, green, and orange, we can expect 99% of our data to be right in here. That means the other 1% of our data is an outlier. It really skews things one way or the other. Now, if we have a high standard of deviation, that means our data is really spread out. If we have a low number for the standard deviation, that means our numbers are really close together and compact. So there's 2 ways in which we can measure data. One way is we can take a look at its mean, median, and mode. The second way is we can look at how it varies. Its range, which we can calculate, and its standard deviation, which we can interpret. And that is how we can compare, compute, and interpret with statistics.